Hello everybody, and thank you for joining the first episode of Mr. Sim's Symmetry Math. Let's go ahead and line up the stage here. There we go. My apologies about the late recording, but fortunately things helped me out. Problems ensued. They were overcome and persevered. So still managed to make it. Still managed to win. It is still Prime Day right now, for at least another hour or so. This is going to be Prime Mathematics 101. I'm not going to touch on what I do to, or what sort of laws or properties have to be followed in order for these to be successful. I'm just basically going to go ahead and break down the math itself and the elements that are utilized within. And the following episodes will be about the breakdown of how each one of these functions and the sort of different elements that come with prime mathematics that are different than classical, and we'll just go over the ins and outs and all the different laws and properties that I've discovered within this system. But for now, I'm just going to prove to you that I do have a system. Down here at the bottom, we got green is multiplication, blue is subtraction, red is addition, brown is division, and then this green bluish color is going to be for factors. We'll get to that. The black is going to be the base or the root number. So you'll see right here, the number of the day is 37. So there's the root right there, is 37. And then we got this color right here is going to be near. And that should about cover what we need to today. So let's go ahead and just jump right on into it. 3. Let's go ahead and start with 3 times 0, or 7 times 0 equals 0, obviously. So you can throw in the 0 in between 3 and 7. It's 307. That's a prime. And then from here, you can go ahead and do a multitude of things. You could do, let's go ahead and I guess cover all the elements of multiplication real quick. We got 3 times 7 is 21. Equals 21. And since it kind of came over here like this, it actually gets stacked to this side. Equations in this math can be on either side, left or right. In this case, we're going to have 2, 1. So now we have 2, 1, and 307 is going to be prime. By the way, that's what that symbol is right there, is equals prime. And then so then next we can do, and I'm going back each time to the original number. I can build off of any one of these numbers though. But each time I'm restarting the whole thing. So let's keep that in mind. As far as 2,137 doesn't have the 0 in it because I'm not building off of it currently. But that's okay. Let's see, we got addition that we can do. You got 7 or 3 plus 7 equals 10. But we can't do a 10 and have it be still a prime number. So, in order to make that work, you actually have to follow a mirror property that I will elaborate on in my next video. But this happens almost every time, all the time. On the right hand side, the number gets flipped, so it is not three, 7, 1, 0, but 0, 1. 3701, which is still representational of the 10. Everything in this system just has a very weird mirror property that I haven't been able to completely explain yet, but I have been able to completely understand. So that's something, getting somewhere. And you've got subtraction, which would be minus 7 equals -4, but we don't need the negative part, so we're just going to go with 4. Now this one we're actually going to You can do in prime math, you can do numbers on either side of your base value. It's all about these standing equations. This number stays within. You use this the same way that you do with mathematics, but the number itself that you're using still stays in place. So we can go 3 minus 7, you can use it in the middle. 3, 4, 7. So let's see here, we've got some blues. Okay, some blues for subtraction, some red for addition. Here. Okay. So far we've got 37 going to 307, 2,137, 347, 3,701. So, and we've covered, I think, one element. Nope, we haven't covered brown yet. We haven't covered division yet. And division gets a little bit tricky because we've got three divided by 7. And that equals a repeating decimal of 4, 2, 8, 5, 7, 1, 4. And actually, it's going to be a repeating decimal of 428,571. And when you have them repeating on a loop like that, see, they're going to be something like, let's see here, do something like 3, 7, 4, 2, 8, 5, 7, 1. Or you do it backwards. 7, 5, 8, 2, 4, 3, 7. And I haven't double checked all of these to verify for sure if they're prime or not. This is just part of the mathematics. You can always feel free to double check them as I will too. But use of tools like division and multiplication actually get more accurate the further down the line that you get. And so yeah, just keep that in mind as well. So let's see, what else do we have here? I think we're going to go ahead and step on to the next set here. Pick one and keep moving on. So let's go ahead and go with, I guess, a multiplication value of 2137. So we've got, next one is next baseline is 2,137. Which, once again, not entirely sure on this one, but I'm pretty sure that you could have set maybe. You could set 21 over on this side, but it would take proper placement of a 0. It would have to go 30721, I believe. But I will touch on that in a further video as well. This is all just basic right now. Well, let's go ahead and do 21 and 37, or 2137. So we've got 21 plus 37 will equal 58. Might not work. I think close. Right, yeah. the hell, let's try it. We'll say that 582,137 might be prime. You could also do also got something like 7 plus 3 plus 1 plus 2 equals 13. And this one I am much more confident in. Some of these you get the power option as well of you can inner switch them as in 213,713 as a prime, so is 132,137 as well as 312,137. So there's some more addition for you. Do a little bit more subtraction here. Got -3 -12. Subtraction, we could do 7 minus 3 is 4, minus 1 is 3, minus 2 is 1. So 1,121,000. 1,312,000. What the fuck? No, I'm starting from up here, my bad. 21 minus, let's see, 37 minus 21 is 16. So you've got 6, 6. Two, 1, 2, 1, 3, 7. Also potentially could be 2, 1, 3, 7, 6, 1. And if we wanted to go down here to make this one grow, the 3, 1, 2, 1, 3, 7, we could do 1, 3, 1, 2, 1, 3, 7. So 1,312,137. And also I believe we could do 1,132,000. Well, let's touch on some more multiplication. $21 times 37 equals 777. So $7,772,000 137. You also might be able to do 2, 1, 3, 7, 7, 7, 7, as well as potentially 2, 1, 7, 7, 7, 3, 7. There's a rhythm or a pattern that starts to develop, and as you kind of continue to have these numbers evolve, you'll begin to see the system that does or doesn't work, and once you kind of get into it a little bit, you start to notice how things, how the flow goes, and you're able to adapt a little bit more, adjust accordingly. Yeah, just make certain things like that work. I believe also on the addition, we could have done 3,121,371. See here, we got 3,000,000 12,137 or 1,320,000 So, there's a few of the basic elements. We're out of time today. Unfortunately, I didn't get done or invest as much time as I wanted to into this. My apologies for that, but I can go ahead and continue building off of these now that you've seen how a few of the basic elements are done. I can continue to build off of this and go ahead and start seeing what else is working on here. Because I'm pretty sure we could do something like 777213777. As crazy as that sounds, but yeah, start doing things like that. We can start mirroring things. We can start doubling up on what the answers are, and for any of these that aren't prime, I even have a method that I can show you to make them become such prime. But so we got time for today. This was July 2024, the 17th, which was Prime Day. Let's just keep in mind that 7202417 is also a prime. So hopefully this was a prime example of how to use mathematics in a different way, and you know, the something that's kind of outside the box thinking. We will touch base back here again. I have another number to break down, and I'll go ahead and invest a little bit more time into this next one and start really breaking down the system that I use and how all of this becomes what it is. I realize for my very first video that this is probably a little bit sloppy, but it will get better. So thank you for tuning in, and as always, may the numbers be in your favor.